We are going to do lesson 32, solving linear systems with matrix inverses. Before we do that, we need to talk about some of the basic terms that we've already dealt with this year. Additive inverse of an expression. If I had, for example, if I had 4, what do I have to add to that to get a 0? Well, that is just a negative 4. So we're just flipping the sign there. If I had x minus 2, what do I have to add to that to end up getting a 0? That would be negative x plus 2. We just run a negative through what we're trying to find the inverse of. Additive inverse of a matrix, well, we're doing pretty much the same thing. Say that we had this matrix and we wanted to find the additive inverse of that. What are we going to add to it to get zeros in all 4 spots? So what we do, 1 plus what equals 0? Well, that's negative 1. 2 plus what is 0? Negative 2, negative 3, and negative 4. So additive inverse of a matrix is the exact same thing as additive inverse of an expression. Multiplicative inverse of an expression, say that we had 4 again, what do we have to multiply that by? Not to get 0 like we did for additive inverse, but to get a 1. 4 times what gives us 1? Well, that's just the reciprocal of it. 4 times a 4th gives us 1. So what we're doing is we're just flipping the expression. So if we had x minus 2, what are we going to multiply that by to have us get a 1? Well, it's just the reciprocal of this, which would be 1 over x minus 2. Okay, now the question is, can we do that to find the multiplicative inverse of a matrix? And the answer is no. There is a new process to be able to find the inverse of a matrix, which we will go over in just a second. The identity matrix of a square matrix is, well, if we took this back to just a number, the identity would be 4 times 1 gives us 4. This 1 helps us get the identity of it. Okay, and so if we had, once again, if we had this matrix, what do we have to multiply this by to get the exact same thing as an answer? Well, let's try it out. I would say, I think most of you would say, well, we got to put a 1 there. So 1 times 1 gives us 1. 2 times what? Well, that's got to be a 0 to keep our 1. Alright, if we come down here to 3, 3 times 1 is 3, plus 4 times 0 is 0, gives us 3. Now to get this spot here, we've got to multiply this row by something to get a 2. Well, if I go and put a 1 here, 1 times 1 is 1, 2 times what to give us a 2 for a total here? I don't know. So that's not going to work. Actually, if we put a 0 here, 1 times 0 is 0, 2 times 1 does give us a 2. Let's see if it works for the bottom to get this 3 and 4. 3 times 0 is 0, plus 4 times 1 is 4. So yes, this is our identity matrix. And we use that quite a bit, including how to figure out if these are inverses or not. Alright, so what we're going to do whenever you're asked a question like this, it says to figure out if this is the inverse of that. Alright, well what we're going to do is we're going to multiply these together. 3 times 1 is 3, plus 1 times negative 2 is 1. 3 times negative 1 is negative 3, plus 1 times 3 is 3, so that's a 0. 2 times 1 is 2, plus 1 times negative 2 is 0. 2 times negative 1 is negative 2, plus 1 times 3 is 1. That looks familiar, doesn't it? Okay, now, here's the trick though. Alright, that is what we want to find, but to tell if they are inverses of each other or not, we've actually got to flip the order. We got to take this one times this one to figure out if we get the same thing. So let's try that again. So 1 times 3 is 3. Negative 1 times 2 is negative 2. 3 plus negative 2 is a 1. So we're in the right spot right now. Okay, to find this spot, row 1, column 2, row 1, column 2. 1 times 1 is 1, plus negative 1 times 1 is negative 1, gives us a 0. Down here, row 2, column 1, this one, and this one. So, we have negative 2 times 3 is negative 6, plus 2 times 3 is 6. Add those together, we get a 0. And then this times this. Negative 2 plus a 3 is a 1. Since we got that since we did it both ways, and we got this 1, 0, 0, 1, then the answer is yes, these are inverses of each other. Let's try this one down here. 4 times negative 3 is negative 12, plus 2 times 2 is 4. Negative 12 plus 4 is negative 8. Am I going to get one of these? The answer is no, we wouldn't. So these are not inverses of each other. And that's all you do. You just multiply them together, check and see if your answer would be 1, 0, 0, 1. You could get a 1, 0, 0, 1 doing it one way, and then something else the other way. If that's the case, then they are not inverses. So you gotta make sure to check that as you go through this. Now, it would be nice to be able to tell it to be able to figure out what the inverse actually is. Alright, and what we have here is we have the directions for trying to find the inverse of a 2 by 2 matrix. Okay, if A is A, B, C, D, then what we do to find the inverse, and this negative 1 means inverse here, is first, if we look at our matrix, our A and our D are switched here. So we gotta switch these two spots. Our B and our C, they're in the same spots, but the signs have been flipped. So that's half of it. The other part is it says 1 over the determinant of A. Well, the determinant is just down minus up. We gotta figure out what that number is to put right in there. So let's do this. It says find the inverse of the matrix here. So T inverse is, well, if we just find the matrix first, we've got, and switch these two, so 3 and 4, and switch the signs of these two, so 1 and 2. Then we need to do the determinant, so 1 over the determinant, so 12 minus 2 is 10. So we've got 1/10 times this matrix, and then we just got to multiply that through. So 0.3, 0.1, 0.2, and 0.4. And if you wanted to, if you're not 100% sure if this is correct or not, go check it, okay? Take this matrix times this matrix. And then, if they are inverses of each other, we should get that 1, 0, 0, 1. And then just remember, you gotta do it the other way too. So you gotta take this one times that one to also get that 1, 0, 0, 1. Alright, so let's try a couple more of these. Alright, 4, 12, 3, 9. Alright, first of all, the matrix. We gotta switch these two spots, so 9, 4. Switch the signs, negative 3, negative 12. Alright, and then we do the determinant. 1 over the determinant, 36 minus 36 is 0. Can you run that through there? And the answer is no. So there is no inverse for this one. Okay, so it is possible for a matrix not to have an inverse. Alright, it's the same thing as if we took and said, alright, what is the multiplicative inverse of 0? Well, technically 0 is 0 over 1. Alright, and what we've done in the past is we would just do the multiplicative inverse or the reciprocal, and we'd take 1 over 0. Well, can you multiply by 1 over 0? And the answer is no. So that's another example of how you could have something where it's not an inverse. Okay, we can also do these by 3 by 3. Alright, and to make things nice for this year, we are not going to do any 3 by 3 matrices. So that would be more of a next year thing. So what we're going to do is we're just going to get rid of these two rows. We're going to do 2, 0, 1, 0. And we're going to find the inverse of that. Well, remember, switch these two. So 0, 2. Switch the signs. Sorry, that 2 is not in the right spot. 2 goes down here. Switch the signs here. Negative 1, 0. And then we've got to do the determinant. 0 minus 0. Well, once again, that is no solution. So it is possible to get no solution on these. Alright, next one. This would be an example of when you would actually do this. Solve for matrix X. Well, if you were to look at this, we know that if you take this matrix times something, it's going to equal this. Well, if this is a 2 by 2, and this thing is a 2 by 2, this X here also has to be a 2 by 2 to be able to do that. Remember, it's 2 by 2 times 2 by 2. These match up, so then we can do it. These tell us what the dimensions of the answer are. So we do have a 2 by 2 matrix. Now, how do we do it? Alright, that is another question. Normally what we'd say to get X by itself, we'd say, well, let's divide both sides by 5, 4, 6, 5. Alright, and you're not necessarily wrong. That would get X by itself here, but we can't divide matrices. So we got to come up with a different way of doing it. And dividing matrices, it's the same thing as multiplying by the reciprocal. If we had 4x equals 8, what you would do is you would divide both sides by 4, x equals 2. But you could also say, well, I don't want to divide this time. Say instead I multiply both sides by 1/4. Over here, we still get an x. Over here, 1/4 times 8 does give us 2. So it works for both ways, and that's the way that we're going to have to do it for this matrix. So our first step, remember this is like, well, find the inverse of this thing. So our first job is to find the inverse. Alright, remember, flip the spots, well they're both 5s, so it doesn't matter. But then switch the signs here, so -4, -6. And then we gotta do the determinant. 25 minus 24 is just a 1. So our inverse is just this thing. We would just multiply 1 through here and that doesn't change anything. Now, to solve for x, now that we have the inverse, the rule is you have to take the inverse times the answer to be able to solve for x. You cannot do it the other way around. So it has to be in this order here. -5, -4, -6, 5 times 3, 4, 0, 2. Alright, and then we just multiply them out. 15 times 0 is 15. 20 minus 8 is 12. -18 plus 0. -24 plus 10 is -14. And there is our answer for x. If you were to plug this in for x and multiply those together, you would end up with this as our answer here. So that's how we would end up doing that. Now, another thing that we can do with these is technically we can end up solving these types of equations by doing the inverse. We're not going to do that this year though. If you get asked to be able to solve a 3-variable 3 equation, Okay, well, what you're gonna have to do is you're gonna have to do the elimination method. But if you wanted to, say that we had 4x plus y equals 2, and 2x minus y equals 4, well, what most of you would do is, well, I'm just gonna do the elimination method, and you're not wrong, you can do it that way. But you could also say, well, if I wrote a matrix that looks like this, which notice is just the coefficients of our variables there, and I took that times xy, that would equal 2, 4. Well, to solve for xy, if I move this over, I'd have to take the inverse of this. So, -1, 4, -1, -2, and then determinant, so -4 minus 2 would be -4 minus 2 would be -6. Alright, so we'd have this whole thing times -1/6. Alright, and then you could multiply this -1/6 times this, and then multiply it by 2, 4. Alright, now that is much longer and complicated than by just doing the elimination method on this, and I would agree with you. But when we get to solving these later on, what I'll show you is it is way easier to do it this way. Alright, so that's what we're going to get to later on. Alright, if you have any questions, please let me know.